Hi, Jeremy. Thanks for joining me today. I was hoping you could introduce yourself and give
Sure.
everyone the big exciting news.
Yeah. Hey, I'm Jeremy Carr. So I'm a chemistry instructor at Central Alabama Community College, and that is located, we got four different campuses, but our main campus is in Alexander City, Alabama. I don't know if you're familiar with the area, but it's about 30 or 40 minutes as the crow flies to the Georgia border, right in the middle of the state. So I always just tell people it's right under the A in Alabama. But I've been here since 2014. I'm a chemist myself. And yeah, we've been involved with this, calling it the astronomical project, but it's the ISS project. And we are sending a science experiment up to the International Space Station. And this is pretty neat because here's the best part. I didn't design the experiment, it was all students. So that's like super duper unique. And we're looking forward to it. We think it's going to be a great opportunity for them.
Absolutely. Yeah. And that was one of those items that I was hoping you could get more into as far as how do you even get started planning an experiment to perform like this?
That's a loaded question. If you asked me a year ago, how are you going to put students into space? I'm like, ugh, who wouldn't even know where to begin with that one? We got involved with the National Center for Earth Science and Space Education, we call them NESI, back in fall 2024. And it was an email communication where they invited us to participate in this thing they have called the Student Spaceflight Experiments Program, or SSEP. And the idea for it was is that we would host a local competition amongst our students here on CAC's campus, and then the best science experiment that was developed, whatever the top three were, honestly, we would send them up to our friends at the National Center for Earth Science and Space Education, have them review it, and then pick what they felt was the most viable project for going up to the International Space Station. So we entered an agreement with them in January 2025, and that was a big kickoff right there. Started recruiting students, email blasts, social media, any and all students were involved or could be involved, were invited to participate. And we got trying to shoot for, so we were required to have 40 students. And we ended up with, or we needed 45. That's what we wrote in our proposal for them. And we ended up with 52. So not bad for a medium sized 2 year school in rural Alabama. At least I don't think it's that bad. So
Absolutely. Early root development rate of radishes and microgravity. I have a sense of why that might be useful, but I'm sure you could give a much better answer of why that's important to learn about.
we ended up getting about 15 projects in total. Our winning project was plant shoot and root growth amongst radishes. Why that one? That project was interesting. It went through this really strange evolution. So when we presented this project to the students for wanting to design an experiment, the team that kind of first got together, they said, "Oh, hey, let's do something involving mechanical engineering," right? It was very broad. The problem with that, though, is you're only allowed a certain amount of space to work with. I'll show you. This is the actual, this is called the FME. You have to be able to design an entire experiment that fits inside this thing. And it's about 7 inches long, has a total volume of about 10 milliliters. It's about 2 teaspoons. So there wasn't much room really to work with on this one. So their mechanical engineering project went out the window. That slowly morphed into like physical chemistry, and they were going to look at substance viscosity. That slowly morphed into eventually botany. That slowly morphed into something kind of more space astro farming. And then eventually they ended up settling on radishes. Why radishes? They're easy to grow. So there's no light that's required to grow them. They have about 4 to 5 weeks till they reach maturity. Um, they're a pretty sustainable food product, and it's hypothesized by several space agencies, NASA, JAXA, that this might actually be a good source of nutrients for astronauts that happen to be on longer space flights. And that was really the sense behind it, was is that could you grow these in a microgravity environment, and once they were grown, if you brought them back to Earth, how would they compare against radishes that were grown simultaneously under what we call terrestrial gravity? And so that's the goal. We want to compare the two of them, look for any similarities or differences. And then to quantify this, to measure it, we're trying to measure the root and shoot length. So that's pretty simple. It's as simple as just break out a pair of calipers, in all honesty, or ruler. But we'll probably go a little more further into it. We'll break out some microscopes. We might do a little staining and just try to get a sense for, are there any significant differences between how these organisms are grown in space versus on the ground?
Makes sense. In terms of the analysis, what challenges do you expect to face in terms of interpreting the data?
With this stuff, there's always a fear that the results are going to be identical, and so they're going to be kind of boring, right? And that's not, we want to have exciting science. We want to have really like, stuff that grabs you. And that's one reality we've got to face. We could get this back entirely and get the exact same result that we got on the ground. I'm guessing we probably won't. And the reason that we probably won't is because if you think about how organisms grow, think about a tree, for instance, you've never noticed that trees always grow against gravity, right? And so what happens if you pull gravity out of the equation, trick the experiment into thinking that there is no gravity? How would a tree develop? NASA's been after these types of questions for years, and we're hoping to see some pretty significant differences. I will tell you the biggest challenge in all of this has been designing the experiments to fit into this darn FME, right? It's 10 mils is not much to work with. That has been the biggest challenge. But analytically speaking, they could be the same. They could be similar results that come out. That's part of the fun of science is you just do the experiment, you see what the end result is. I hope it's something significant, though. I think it gets a pretty good feeling about it.
Could you talk a little bit about how students actually became involved in the project?
So we recruited the entire school, for lack of a better term. We have about 2,000 students, so email blasts, social media. And what we ended up doing with the students that were interested is we ended up forming a non-credit course. And we've actually had a few universities that have reached out and asked about this. How do you form these non-credit classes, and how would you put students into a course like that? So the course that we developed is something called Proposal Writing for Microgravity Science Experiments. It's coded as NARS 4001, NARS 4001. But it was a class that we met one night a week for 5 weeks, and we basically took the proposal writing process and broke it up into pieces, and then taught the students for 1 hour a night different part. How do you develop a research question, right? Give them the fundamentals of that. You can't just study how does gravity work. Like that's too broad. Like you have to be teach them how to be very specific of how are we going to measure gravitational effects. Make it a bit, that's 1 week right there. The next week after that is how do you go about developing your idea, right? So how do you do the literature search? We have this fantastic librarian on our campus, Leslie Ruiz is her name, and she was just completely willing to help students any way, shape, or form that she could to try to get them the resources they need to develop their projects a little bit. That was 1 week. Another one was how do you go about designing an experiment? You teach the students what is the best way to ensure that you replicate your results. Any scientific standard that we would normally use. Experimental replication, right? Let's teach them what does that mean and how do you take that and put that into words and develop an experiment that's going to be helpful for people to try to do it a second time. It helps with the experimental communication as well too. And I think the last part of it and all of it was formatting it, was teaching them how do you assemble this whole thing together with references and different sections and writing an abstract and adding graphics into this. And it was very impressive watching these students, again, start from nothing and build these beautiful proposals. In some cases, 10-page, single space, 10-page proposals with references. And these are, like I said, 18, 19, 20-year-old students. So just incredible. I don't think I could have done that as an undergraduate. So I was very proud of the work that they had done.
That's great to hear. I'd love to hear your thoughts on how participation in the project has impacted of you and the students, both academically and personally?
I'll speak to the students on this one. So on the academic side, I work with them on a daily basis. Me personally, I've seen anecdotal increase in scientific discussion across the campus. So we're starting to see more and more students interested in wanting to talk about not just like textbook science, more practical science, actual scientific experimentation. So that as a chemist, as a scientist myself, that's huge because that's an anticipated need in the future. We need more scientists in the future. And so for them to have these conversations now is pretty impressive. I don't think I was having this level of conversation at that age, at that 18, 19, 20-year-old age. And it's been meaningful work. And I think they sense how meaningful that the work has been trying to get a project pulled together. On really looking at the personal characteristics of students, one thing that I've noticed and also my team has noticed as well too is we've seen a lot of growth amongst soft skill development. Again, just entirely my viewpoint on this one, but 2020 on led to this really rough nosedive in terms of communication skills, in terms of problem solving, in terms of teamwork. And this project lets students self assemble into teams under competitive spirit. They were getting together off campus. This has not happened before. They were getting together off campus at local restaurants. We just put a Starbucks in near our campus. Students were meeting there at night, 8, 9 o'clock at night to work on their proposals. We just got a Chick-fil-A on our right near our campus as well too. Students are meeting there for dinner to work on their proposals. So that's the type of stuff. I remain in contact with a lot of organizations across the country and businesses, and I ask them, what are you looking for in your employees? And 9 times out of 10, they're telling you soft skills, right? They want those problem solving skills. They want those communication skills. They want that teamwork. The technical stuff, students can be trained in all that kind of stuff, but it's the things that you don't normally teach them out of a textbook, but you're giving this project gave students opportunities to really learn how to flex those muscles a little bit. And so that's been really nice to see that, and hoping it's going to translate into some really strong candidates for employment at some point in the near future. We had a discussion. President of our college and I had this discussion. Jeff Lynn, he's an amazing person. We're discussing about like what's the payoff for a student that's going to be involved in a project like this. We train these students in how to write grants, scientific grants. Now, are all these students going to become scientists? Probably not. But at some point, they may be asked to write a grant of some sort of whatever job it happens that they're whatever field they happen to end up wherever they're employed. And having a little bit of familiarity with that process and understanding that grants are competitions, that's worth its weight in gold right there for students. And what do we want? We want our students, it doesn't matter if you're a student from CAC or Assumption College University or the University of Alabama or Harvard or whatever. You want your students to be competitive at the end of the day. And opportunities like this really open that door for them to at least explore it a little bit.
Absolutely. You had talked about the students 8 or 9 at night working on their proposals. One thing that was really interesting in reading everything over was that you were also involved in a project that received honorable mention for a
Yes.
separate proposal. I'd love to hear some about that.
Yeah. This one, so I teach a class, I teach organic chemistry here. It's a very small enrolled course, again, rural Alabama. And so I'll have, every time we offer the course, I'll have 4 or 5 students that want to take it. And the dean just begrudgingly says, sure, we'll let the class make. But you get to work with these students on a really close level. And one of the techniques that they learn in Organic Chem 1 is they learn infrared spectroscopy. And I just had this one student this last fall who she just fell in love with it. I don't know what it was. I don't know why it happened, but she just did. And that's all she loved. She loved the fact that you could measure the strength of a bond just by shining infrared light on it. And so, in any case, this project starts up and she's interested in getting involved. And she pulls me aside one day and says, I want to do something, but I don't know how we would get an infrared spectrometer onto the International Space Station in 10 milliliters. And so got together and I said, all right, I didn't want to give her the whole punchline, but I said, hey, let's look at a couple experiments that might be of interest to you. I'll be happy to coach you through it. I'm not going to guide you through this at all, but you think about what you want to work on. Gave her a couple weeks to work on it. And she came back and she said, proteins are very difficult to grow in space. Proteins really break down into amino acids. Do we understand how amino acids crystallize in space? And more importantly, can we take those crystals and measure them using an infrared spectrometer? And I was like, heck yeah. So go Elisa. Like she was awesome on that. I just putting all the little pieces together. And so she was really the driving force, her and I think she had about 3 or 4 other students that were in that group. And they put this project together. And really it wasn't until the tail end of the project where she reached out and said, we're going to need a professional advisor at some point. Would you be willing to serve as our advisor? The work had basically been done. It was more of a go through their proposal and just double check it as a peer review and just make sure that all the T's were crossed and the I's were dotted and the science was pretty logical. And that was my involvement with that mostly. They did reach out to a couple of researchers across the country. They reached out to Kevin Shaughnessy, who's at the University of Alabama. He's an amazing professor there, and asked him about crystallography and would there be a chance to do like XRD analysis if necessary. And he offered to, if the project was selected, at least explore the opportunity of working with that. We looked at doing some computer modeling also. A friend of mine is Greg Chumper, who's at Missouri S&T. He's a quantum chemist. He's brilliant, absolutely brilliant computational chemist and an AAS fellow. And he offered to help them with, if necessary, if we needed it, some computer modeling. So yeah, I served as their professional advisor, but they did most of the work themselves. And it was just mostly me cheering them on, going, just go team. And as a teacher, this is one of very few moments where you just kind of sit back and you watch your students just go. We don't see that often as teachers. We see them perform well on tests, we see them perform well in labs, but now it's go. What can you do? And then just to put something like that together is beautiful. And I was very proud of the fact that they were an honorable mention. I would have liked their project to have been picked, but there was a lot of great projects this year, just outstanding quality projects.
Did any of the other ones stand out as especially novel to you?
There was a couple of them that really jumped out at me. I had this one student who lives near Montgomery, so she lives about an hour from us, and she works in a women's clinic. And there they do bone density scanning. And she drove all the way to our campus one day, sat down with me and said, what do I do? I'm interested in bone density and osteoporosis. And I said, what if you were to take bone samples and grow them in different media or subject them to different media in microgravity situations and see what happens to the bone sample? And you can do that in space. I said, the sample fits inside the FME. Sure, why not? And she went home and she researched it, came back about a couple days later and said, this is what I came up with and this is what I'm thinking about doing. And the women's clinic said that they might even be able to do the bone density scanning for me. I was like, sounds like a great project to me right there. That one jumped out at me right there. I had 2 students, they were high school students that came up with doing astro-dentistry. So they wanted to look at enamel decay in a microgravity environment. That jumped out at me. I had another team that wanted to look at Aspergillus niger, which is like a black mold almost. And they wanted to see how that grew. There's a lot of research involving its growth in a microgravity environment on the ground, so you can simulate it on the ground. They wanted to take that project and actually bring it up to the ISS. Brilliant idea. A lot of safety hazards associated with that, though. That one was trickier to get that one ranked higher. But yeah, we had some fantastic projects. And I'm just, to this day, I still talk to my colleagues here around, and you just can't believe what these students were capable of doing in 2 months worth of work, being able to put together a complete scientific proposal. Just outstanding work that they have done.
Absolutely.
Yeah.
So what do the next steps look like in terms of how the winning proposal is actually seen through from where we are now to even sharing the results with the broader scientific community?
Sure. Yeah. This is a good question. So the way it's going to work is we are going to use the summer. We're working with the team. We're getting together here in a couple weeks to try to optimize the experimental conditions on the ground. So we're going to do a series of experiments. The team has a professional advisor at Horseshoe Bend High School, which is in New Site, Alabama. She will be helping guide us through this and try to optimize the right conditions that we need. Once we have the conditions all fulfilled and we feel confident in the results, at least on the ground, then what we'll do is we'll take that entire experiment and we'll submit it to NESE, the National Center for Earth Science and Space Education. And then what they do is they pass it off to their partners and it gets reviewed for safety at the highest level. So actually, NASA will do a safety review of it, as I understand it, to make sure that there are no outstanding issues that could cause problems during spaceflight. Then, once that's done, they'll presumably come back and make some recommendations as to things that we may need to change for it. We'll make those alterations as necessary. We'll bundle everything together, and then we will FedEx it to Nessie's partner, which is down in the Houston area. It's a company called Nanoracks. They bundle everything together. It's called payload integration is the big fancy term for it. And then that gets sent over to Florida and then gets loaded up onto rocket at Kennedy Space Center. We don't know exactly what rocket it's going to be, but most likely it'll probably be a SpaceX rocket that will be sending our sample up to the ISS. It's currently scheduled to depart April 2026. So we have a little bit of time, which is good, gives us a little breathing room here, but we want to get all the scientific experimentation done and pulled together so that there's no hiccups when this thing actually does go up to the ISS. And I'm not sure if you're aware of this, but the ISS clock is ticking. Next several years, they're going to deorbit that thing. And so we're like trying to get this up there as quick as we can before it does become deorbited. Eventually, about 2 months after that, we'll get the payload will come back to Earth and then it will get sent back to us. We'll do some analysis and then we will hopefully publish the results. That's the goal.
That's awesome. Yeah, that was my next question. So a 2 month window.
Yes.
Okay.
They tell us it's about 4 to 6 weeks. In looking at the previous missions that have gone up there's been about 300 missions that have gone up there. I feel comfortable in saying it's about 2 months. And that'll be good. That'll be plenty of time to get the experiment done the way we need it done. And then, of course, send it back to us. And then we can take a look at the results and take our time with it. There is an interest, though, I will say, of taking those space-grown radishes and wanting to plant them on campus. That'd be so cool. We think that might be a fundraiser for us. So you could buy space radishes if you're in the Alexander City area one day. Maybe that'll pay for scholarships.
That's very cool. Yeah.
Yeah.
Let's say someone is listening to this and they're interested in some sort of space related research, whether it's a student or a professor. How would you recommend someone fitting those profiles get involved if they want to pursue something in this area?
So if you want to get involved with NESE, do a Google search for SSEP. So that's a Student Spaceflight Experiments Program. And they have a whole website that's dedicated to this. They list all the upcoming opportunities for spaceflight there. And you can get involved with this if you want to. It's entirely what you want to do. If you don't want to go into that area and you want to just go into the broader aerospace kind of experimentation, just jump in with 2 feet. It's aerospace, I'm finding, is it's an interesting combination of broad STEM fields. So there's chemistry, there's physics, there's bio, engineering. It all blends together. And putting it in dollars and cents, the U.S. aerospace and defense industry, the A&D industry, it's about $1 trillion. And why I'm saying that is because that is a massive industry. And so there's a need for experimentation to advance that industry. It's only going to grow at some point. Give it time, it's going to grow. So if you want to get involved with doing just general science for the sake of science, which is great, commendable, this is a great place to go. If you're looking at trying to get involved for trying to get some advancement going on, absolutely this is a place to go. We meet with every once in a while, we'll get solicitations from recruiters in the state. And recently, within the past year, had a couple from the aerospace industry in our state. And the message has been really interesting. If you have an interest in aerospace, they want to hire you. And why? They're so confident in the growth within that field. Go for it. There's employment opportunities that's right there. But then there's also those just general scientific curiosity, wanting to get involved with some of that stuff. The community is also really good too. I have found some of these researchers, like mentioned the Aspergillus niger experiment, the student found the actual researcher who did that work recently, a couple of years ago. Researcher published the work, and the student actually emailed that professor, and the professor offered to guide them through the experiment, which I thought was outstanding. So there's a lot of love in this field, and there's a lot of people that want their peers to succeed. So this is a great field to get involved. If you're interested, step up, go do something of interest in that particular field.
Makes sense.
Yeah. One other thing I'll point out too,
Yeah.
that has been it's come up in a couple interviews. People have been asking about how rare this project is. You don't hear about students that are sending an experiment up to space. I have to be careful how I say that, because when the project first was announced, I had students that were meeting in my office, shutting the door and saying, "Can I volunteer to go to space?" And like they totally missed it. We're sending the experiment to space. As much as I would love to send you to space, I'm sure you would love to do something like that. We're not sending students up there. It costs $55 million to send a single student or send an astronaut to space. But that said, the rarity in this project, though, if you look at National Center for Education statistic data, US data, we have about 100,000 schools within the United States. If you count kindergarten all the way up to really like the 16th grade, right? So you think about it to senior year college, public and private schools. Only about 300 schools have really participated in SSEP. In a roundabout sense, we're talking about less than 1% of the schools actually participating. So that is, I am super duper proud of that. And I know the students are proud of that. I know my president is like beyond proud of that, about how rare that is. And it's just very thankful for an opportunity to do something like this. And again, if your viewers or your listeners are interested in it, I encourage you to go explore it. It's a great opportunity. And the whole team at the National Center for Earth, Science, and Space Education is phenomenal. They've been great to work with. Jeff Goldstein has been our point of contact up there, and he's just a great team all the way around.
This specific project and the opportunity to interview you, it just seemed like such an important, unique thing that we had to do something to help spread the word about, one, this project, but then also hopefully inspiring other people who are interested in pursuing this, because it would be great to have more people involved.
Yeah, absolutely. It's definitely a rare opportunity, scientifically speaking, but it's been a fun ride. It's been a ride. It's been a fun ride. It's a bit of work, but at the end of the day, I enjoy it. I love coming home and telling my kids about what's been developed and what's been happening. And I think my wife is very patient with me about this too. And I've just, for about 6 months straight, it's all I've been talking about is ISS this and ISS that, and she's just kind about it, and she's so I owe her proper recognition for that one. But it's definitely been a good trip overall.
To change it up, you could always talk about the coffee separation here of going in the other room.
I like it. Yeah. If I can only isolate that caffeine, I had to I'm so sorry about this. I had to cheat on you and your community. I had to recrystallize it. Sorry. I'm an organic chemist.
I really appreciate the time today. Maybe in the future we can touch base again. You can do a recap episode, and we can go back over the results or just even how things are going. It's not like we'd even have to wait till next year, but I'll certainly include links for for everything. And I really
Yeah.
appreciate you sharing your story, the student story with us today.
Thank you for inviting me. This has been it's great. Becoming a fan of your podcast here, so this is really appreciative of having me on to talk a little bit about this project.
Absolutely. Thank
Yeah.
you.